Welcome to the TOEFL Listening section. In this part, you will hear one or more conversations in an academic or campus context, such as a discussion between a student and a professor, or between two students. You may take notes while listening. Listen to part of a conversation. You will hear it only once, so listen carefully. After the conversation, you will answer questions about what you heard. Some questions will ask you about main ideas and details. Others will ask about implied meaning, speaker attitude, or how ideas relate to one another. Use both what is stated and what is implied to answer.
Good afternoon, Dr. Morales. Thank you for meeting me during office hours. I wanted to go over ideas for my paper on groundwater depletion solutions.
Good afternoon, Samir. I am glad you stopped by. Tell me what angle you are considering. Are you focusing on engineering solutions, policy measures, or a mix?
I thought a mix would be best because the literature keeps saying single fixes do not work. I want to understand which combinations are most effective at restoring aquifers and preventing subsidence.
That is a sensible approach. In practice, we often combine managed aquifer recharge with demand management and regulatory tools. For example, artificial recharge and conjunctive use can raise water tables while pricing and irrigation efficiency reduce withdrawals.
Can you explain conjunctive use again? I am a little fuzzy on how that works in a managed system.
Conjunctive use means operating surface water and groundwater together to meet demand. It can involve storing surplus surface water in aquifers during wet years through recharge, and then using groundwater during dry spells. This reduces peak pumping and can limit long-term drawdown.
So that is like groundwater banking, where cities store water in the subsurface for later use.
Exactly. Groundwater banking is a type of managed aquifer recharge. It can be done by spreading basins, injection wells, or even by allowing floodwaters to infiltrate intentionally. The choice depends on aquifer transmissivity, porosity, and water quality constraints.
You mentioned water quality. What are the risks of recharging with treated wastewater?
Treated wastewater can be a reliable source, but it requires advanced treatment to avoid mobilizing contaminants or degrading native groundwater quality. Trace organics and nutrients are concerns. Also, clogging of infiltration surfaces and changes in redox conditions can affect permeability, so monitoring and pretreatment are essential parts of the solution.
What about demand management? You said pricing and irrigation efficiency help. Which measures have real impact in agricultural regions?
Several measures are effective. Drip irrigation and precision irrigation reduce volumetric use by delivering water to the root zone. Deficit irrigation strategies can maintain yields with less water. Tiered pricing and metering give farmers incentives to conserve crop. Switching to less water-intensive crops also works, especially when combined with technical support.
Are incentives better than strict pumping limits?
Both have roles. Incentives like subsidies for efficient irrigation equipment can encourage voluntary adoption, while regulated pumping limits set boundaries to prevent extreme exploitation. In many cases, enforcement is the weak link, so combining legal limits with economic incentives is more practical.
You said enforcement is weak. Why is that?
Monitoring historically has been sparse. Many regions lack enough observation wells to track localized drawdown. Illegal or unmetered wells complicate enforcement. Even where data exists, agencies may lack resources or legal authority to penalize overdraft. So data collection must be matched to governance capacity.
How can monitoring be improved?
A mix of approaches helps. Satellite remote sensing can estimate changes in storage and identify hotspots. GRACE and other missions have given basin-scale signals. Ground-based networks of piezometers provide local detail. Telemetry and smart meters allow near real-time tracking of pumping. Combining these tools gives robust evidence for management and enforcement.
Are there examples where these combined solutions worked?
Yes, several case studies stand out. In the Central Valley in California, managed aquifer recharge pilots combined with temporary pumping curtailments and water transfers to the underground storage contributed to measurable stabilization in some subbasins. In Israel, conjunctive use with treated wastewater reuse and efficient irrigation cut net extraction significantly in irrigated areas.
What about places with severe subsidence like parts of India or Mexico can recharge reverse subsidence?
Subsidence from compaction of fine-grained sediments is often irreversible at the pore scale, but raising groundwater levels can slow or stop further subsidence. Artificial recharge reduces effective stress, so it can prevent additional settlement even if past compaction cannot be undone.
So recharge is critical, but not a silver bullet.
Precisely, you also need institutional reform, land use planning, water rights adjustments, stakeholder engagements, and financing mechanisms. All these elements affect implementation.
How do you engage farmers who rely on pumping and may lose access under new rules?
Stakeholder engagement must begin early. Programs that offer transition support are essential. For instance, water markets can let users sell conserved allocations. Incentive payments for fallowing or switching crops, plus technical assistance for efficient irrigation, reduce the economic shock.
What about long-term funding for recharge infrastructure?
Public-private partnerships, dedicated utility fees, and environmental bonds are options. Grants can kickstart projects. Grants plus user fees create sustainable operation budgets. It is important that financing covers monitoring and maintenance, not just construction.
This is a lot to cover in one paper. Should I focus on evaluation of solutions or propose a framework for implementation?
For a university paper, a comparative framework works well. You can evaluate solutions along criteria like effectiveness, feasibility, cost, social equity, and environmental impact. Then apply the framework to 2 case studies to show how context affects success.
That sounds clear. I will analyze managed aquifer recharge, irrigation efficiency, and policy instruments, and then test them on the Central Valley and an irrigated district in India.
Good plan. Make sure to include metrics like change in storage, reduction in pumping, cost per cubic meter, and social indicators such as impacts on smallholder incomes. I can recommend sources for monitoring methods and cost estimates.
Thank you. I will draft an outline and send it to you next week. Would you mind if I include the example you mentioned about the Central Valley Recharge pilot?
Please do. The Central Valley example shows how combining recharge, water transfers, and temporary curtailments can produce measurable recovery in stressed basins.
One more question. Should I discuss climate change implications in the paper?
Yes, climate variability affects surface water availability, which in turn affects the feasibility of recharge. In your framework, consider the reliability of recharge sources under future climate scenarios.
Thanks again, Dr. Morales. I will incorporate these points and include recommendations for monitoring, incentives, and governance.
You are welcome, Samir. I look forward to your outline, and remember to balance technical details with policy realities.
Listen again to part of the conversation. Then answer the question.
Monitoring alone will not stop depletion unless it is tied to enforcement and incentives.
This concludes the conversation portion. For more TOEFL practice tests and study materials, visit Spinta.org.